Hello friends, welcome back to the bench. Our patient is a board that we took a look at when it was fully assembled. As you can see, I disassembled it, removed all the heat sinks. This is the MSI Meg. Now this is a really nice board. So this is one of those boards that comes with a price tag of roughly $1,000. So it's a pretty serious board. Now it came here for a free socket replacement, which last time we looked at it and I just bent the pins back into position, and I figured this should be good. It doesn't need the socket replacement, but the pins were bent because Trevor was trying to diagnose what's wrong with it. And I have a description of an issue. CPU underperforming and RAM issues when loading the provided Expo or Hynix profiles. The PC would work for a while, then crash, but Windows 11 was unable to boot again due to blah blah blah, reinstalled Windows, few hours of stress testing with 3 different stable BIOS versions. So basically there was a lot of work done on it as far as diagnosing. So my initial idea was that, well, maybe it is a BIOS issue, right? Because the subtle issues can result from the socket damage, of course. But as far as we know, the socket was damaged afterwards. So the issues came first and then the socket was damaged. As far as the socket replacement on this one, look at the outline. It is horrible. See, this is probably the worst outline I've had so far. See that? It's gonna be very difficult to align. See, it doesn't touch this line, right? So it's separate from this line. It goes over this line and over this line, and it also doesn't really align with this one, but close enough. Like nothing aligns here. So the alignment is going to be a challenge here, so we'll see. No guarantee, unfortunately. But if we know that there are issues with memory, issues with RAM, unfortunately Trevor did not go into details regarding what exactly were the issues with RAM. And I assume the chips were replaced to figure out whether it's the RAM that is responsible or the board. So I assume it was concluded that it's the board that is responsible. So when things like that happen, first thing that I do is obviously, and we did that before, I measure the resistance on the vCore, IO, SA, and GT. And as you can see, we have 100 ohms, like almost exactly 100 ohms on I think this is IO. On this is definitely vCore here, and we have, it's rising, which is good. 82 ohms, 80 some ohms, and the same on multiple lines over here. And it goes to roughly 85 ohms. So this is not typical. Typically, on the output of these rails, when the CPU is not installed, it is open line. It still grows, right, if you connect it, because the caps are charging. So the resistance is growing, and it usually goes either to open line or gives you like some mega ohms or hundreds of kilo ohms. Which means we cannot measure the capacitance on that rail, right? Because if you have such low resistance, you're not going to be able to measure capacitance. So if we try to measure, come on, and it's OL, right? And the same on all the other ones. So with the resistance measurement showing 100 ohms or 80 ohms, there's no way you're going to be able to measure the caps in circuit. So one possibility is that there is a crushed cap, ceramic cap, and sometimes it is actually pretty common. You measure and it's like low resistance, you inject voltage and it suddenly drops to a dead short, right? You inject like 1 volt and it's grabbing 1 amp. So let's eliminate that first, just in case. So let's inject 0.9 volts. 0.9 volts is not going to break anything on the V-core, especially since the CPU is not installed. So if we're going to start grabbing too much current, that means that we have a crushed cap somewhere, and it should be relatively easy to find it with a thermal imager. So let's inject, and 4 milliamps, and on V-core 5 milliamps. Yeah, so it's not turning into, here we grabbing 0, no, 7, 5, yeah, and it's not growing. So this is fine, meaning that this is not crushed cap. If it was, the current would just go much higher, and it doesn't have to be huge, but if it's like 100 milliamps, then you know that mathematically it doesn't make sense, right? So this might be good, although I've never seen that on any other board, but this is different board, right? This is like relatively high-end board. I mean, realistically, you can sell it as used for around $500. If you want to buy it new, it's like $950, $980, right? It's close to $1,000. It can accommodate 4 M.2 drives. We got 2 USB 3.0s, plenty of IOs, and you can see how many coils we have here. So it can pull some serious CPUs. We have 2 8-pin connectors for V-core. So the other possibility for subtle issues is dry caps or faulty caps. Basically, we don't have proper capacitance on the output, or we have high ESR on the output. So since we have issues with memory, now I couldn't find a board view for this board, so we're gonna have to use some guessing here and there, but my guess is that this is DDR5, so what was it, like 1.9, maybe 2.1 volts on it. So this is most likely the coil that supplies memory, all 4 memory slots. Okay, so what we're gonna do is check the capacitance on the coil directly. 2.1 millifarad. That is huge. That is huge, but it will be big if we have low resistance here. So let's check resistance, and we have it's growing, obviously, because caps are charging. we are past 3K. No, it's actually 2.99. Yeah, 3K. So 3K, that is large enough, or the resistance is high enough that I would expect more reliable capacitance measurement on this line. Let's check. So this coil over here is unusually large, so I'm not sure. Maybe this one is for memory, but what would... No, that one's definitely for memory. Well, definitely it's a bit overstatement because we don't have the board view. We have 8 mega ohms on this coil, so capacitance on this rail will be reliable. Let's see what it is. It's not showing anything. Let's try again. It's not catching. So let's use fluke and see what the fluke says. If it's low capacitance, fluke can be more accurate. It's growing 9. It's fluctuating around 9 nanofarads. So 9 nanofarads is low. So this is definitely not the memory rail. This will be that additional voltage that also goes to the memory, but it's not a supply voltage. I'm not sure what it supplies, but it is a additional voltage that is required for the memory to work. And now capacitance on the output is low, but in this case it can be low because we only have ceramics on the output, and this isn't the supply voltage. So low on this line is fine, but huge capacitance on this line, right? It should be 56 times 4 plus ceramics, so you know, few hundred mics on it, not 2,000. So we're having high capacitance reading on the output here. Now what does that mean? That usually means that we have high ESR. And high ESR, it might manifest in subtle ways, basically. That it's not going to be just not working, although depending on how power supply is designed, it might not turn on, depending on how much how the feedback is built. The typical ATX power supply will not turn on if the ESR on the output is too high. If the capacitance is too low, the same thing. If there's too much resistance on the output, same thing. But those are much more sophisticated feedback circuits. Over here, we're getting 5 volts and we're dropping it to say 2.1 to supply the memory. So the feedback is not that crucial, so it might not be that sophisticated. I gave it a thorough visual inspection on the memory and pretty much the entire board. I don't see anything suspicious. I also did some measurements here and there as far as resistance and voltage drop and all that. Again, I don't see anything suspicious. But what I did notice that is concerning is that the board is deformed ever so slightly, but it's deformed. Now that is surprising to me because we have a back plate. It holds only on like 3 or 4, 1, 2, 3, I think 4 is over here, I'm not sure, 3 maybe 4 screws that are holding it, but I would expect that it would keep the board from flexing. this board has flexed a bit. So now here's the problem with this. If the board is deformed, you can expect subtle issues. That means the board was not installed properly in the case, which happens. Sometimes it's the case that is deformed, especially if it traveled in the poorly packaged and it traveled a long time with or a long way by UPS ground. So it could have suffered many falls and kicks and frustrated UPS workers, and it could have bent, right? It could have deformed. The other thing, maybe one of those pegs was not tied in all the way, so it was a little higher, causing the board to deform that way. And I wanted to check that actually before performing anything on it, because we still have to replace the socket. Because, well, that's pretty much all we can do. The other thing that we can do is recapping. If my hunch is correct that we have high ESR on the caps or we have low capacitance, but since we're reading very high capacitance, then probably ESR is through the roof, then that could help, right? Because if we have fluctuating voltage on the memory, then yeah, all kinds of issues are gonna be there, right? Again, I don't know what kind of issues there were, but high ESR on output caps would explain problems with memory. Unfortunately, I don't have these in stock. I have much larger ones, but I'm not sure if that would be good to replace them with much larger ones. Right, they will fit, but that's going to be much higher capacitance. Because you might think that we require say 100 mics on the output, and if we put 600 mics on the output, that should be better. But the higher the capacitance, the longer the charge cycle. That might fool the feedback circuit that will identify that as a short on the output. So depending on the design of the converter, of the power converter. But my main concern is the deformation of the board. And when I replace the socket, it will deform even more, right? Because I have to heat it up. Now I will try to do it in one cycle, because this is AM5 socket. It's a lot easier to do it in one cycle because it's easier to scrape the solder and clean the board, because you don't have to worry about the caps inside, right? So I might be able to do it in one cycle, but last time I didn't have much success with that. So I'm not sure if I'm going to try that in one cycle. I might do it in 2 cycles. The board is relatively thick, but I would expect this one to be thicker for the price it comes with. It seems a bit more flimsy than I would expect, and that's probably why it deformed. Also, the other possibility is that it was not properly installed. Sometimes you just think, well, I'm just going to install it on this one and this one, this hole and this hole, and I'm going to skip this one, or vice versa, just these two, and I'm not going to put any support on this line over here, right? 1, 2, 3 over here. And that also might cause deformation. And for some reason, a lot of people just care about cable management, so it looks good, more than actually thinking about where those cables are going and how they are flexed and whether they're put any tension on the board. And I personally disagree with that approach, because it really doesn't matter what it looks like. The main issue is that we don't want the cables to go through places, especially the ones that carry a lot of current, go through places where they might cause some kind of interference, and we don't want the board to have any tension on it, because we try to, you know, put the wires behind or something like that. And so even if those wires are hanging and stuff, I say that's good, especially when they're hanging and you feel that they're not putting any tension on the board. But technicians that do that tend to disagree with this approach, and that the cables need to be nice and tight and stuff. Well, maybe for shipping sake or some, but no, I say no, it doesn't have to look good, it has to be reliable. So maybe that's what caused the damage, the flexing. Also on this board, this is probably, well, relatively unusual. Typically, this is the area where you connect vCore, right? And it goes to CPU over here. But on this board, it's right by the memory, right? Which is pretty cool, because you have the main power supply here, right? This is the extended one. And right by it, you have vCore. So this is pretty cool. But maybe that's what caused the deformation of the board. But to sum up, we may have faulty caps, which we'll maybe replace, and the fact that the board is deformed could be responsible for those subtle issues. And we'll see after the socket replacement, we'll see if that does anything to it. But I wouldn't think so. But at this point, you know, the socket is damaged, so we have to replace it. No way around it. All right, let's get to it. Okay, the socket is resoldered. This was so far the most challenging board I've ever worked on. And I don't know if you guys noticed on the speed up footage, but 235 and the socket would not let loose. I mean, one corner would go pretty high, but the other corner wouldn't. And even when I moved the heater, the top heater, a little bit to the left to heat up that corner, it still wouldn't let loose. Now, my explanation of that, why was this so challenging, it took pretty much my entire Sunday. I was gonna finish the Surface laptop also on Sunday, but didn't get to it. My explanation is that there's just a lot of copper on this side of the board, right? And it just soaks all that heat. And what I had to do, increase the temperature to 240 degrees, and I think I even went as high as 245. I don't remember. You can check the footage. That finally let loose, but just barely, just absolutely barely. Then scraping didn't even make a dent in it. This is not only the board seems to soak a lot of heat, which is weird because it doesn't seem very thick, but there must be plenty of layers of copper, and they might be large in size and area. They might have a pretty significant area, and that's why it behaves this way. But the solder itself also seemed like it was some kind of weird alloy. And that got me thinking, could the issues be caused because of that solder just had, the composition of the solder was I don't know, prone to cracking. Maybe there were some cracked solder joints underneath the socket. Possible. I actually had a thought today what those issues could have been, especially under stress testing. I'm pretty sure Trevor did check the temperatures, but I would look into overheating, because when I read the description again, it kind of seems like it might just be overheating, nothing more than that. And it went through a ultrasonic cleaning cycle. Now, as you can see, the socket is aligned. I was afraid of aligning this one because I knew it would be an issue, because you can see how inconsistent it is, right? It goes a little bit to the top, right? It kind of aligns with this line, but not with this line. And on the left and right, it goes across the line, right? It goes outside the line. But there's actually, when you remove the socket, there's another outline inside that you cannot see right now. But that kind of helped me aligning it. So aligning was actually not that bad. I was more afraid of that aligning than anything else. But I did not expect that it would give me so many problems just desoldering. Then when resoldering, I will review the footage. I haven't yet, but I will review the footage when I'm editing this video. I did not see the socket actually drop. Now this is very minute movement. It's sometimes very hard to catch, especially while you're working on it. You're not looking at the screen all the time. You're looking, it's not easy. So during the editing, I might catch it when it dropped, but I couldn't see it drop. So I went again with higher temperature, and just to ensure that that it will definitely, that the solder will flow. This is one of the two sockets that I got from the different source, so perhaps this one is different. I don't know which ones have leaded solder, which one have lead-free solder, so I just assumed this one is lead-free, so I went high with the temperature. So I used pretty much the same temperature I used for desoldering, which brings me to my point. You guys hate when I say that, but yeah, copying someone else's numbers, it's not gonna guarantee success. It's actually gonna guarantee failure. You need to come up with your own numbers. I mean, feel free to copy my numbers. They're, published, and I talk about them a lot. But in case of this board, if I haven't done this, like 10, 15 times at this point, I would not know what to do, because it didn't behave like anything else that I worked on. So you kind of need to, gain enough experience to know whether your temperatures are working or not, and to know whether you have to go up in temperature or lower the nozzle or move the board. It all comes with experience. Also, I didn't show you the humidity, but humidity was at 20% when I started. I did try to bring the room humidity down to LL on my on my hygrometer, but I couldn't. It's just it's winter in Georgia, so it's pretty humid. Plus, I have always window open with the fan in it to ventilate the room. So even with I kept the space heater for, I don't know, like 20 minutes, half an hour before I started. I brought the temperature of the room to like 80 degrees, but humidity wouldn't drop below 20%. So it did drop after the procedure was done. So I kept it on the preheater a little longer at like 50 degrees. The other thing that I've changed, as you know, I still have a lot of issues with keeping the thermocouple in the same place and flush on the board. I'm still waiting for the other thermocouples that might perform better. But for now, what I did was very simple. I just used much larger piece of Kapton tape, right? So I put thermocouple here, and the Kapton tape would go, from here to here, right? And that plus I cleaned the board beforehand. And that actually did the trick. The Kapton tape and the thermocouple remained in position for the duration of the entire procedure. And yes, I managed to do it in one cycle, so I didn't have to cool down the board for cleaning and then reheat it again. The cleaning itself, it also took a little while, and that solder, something different about that solder, or more likely, probably the solder is just standard lead-free solder, but it's the board that just requires a lot of heat to get the solder to flow. So that probably was the problem. Other than that, since it went through ultrasonic cleaner, if there were any issues with memory resulting from dirty pads or something like that, then that problem should be removed. Also, everything here got cleaned very nicely, all the drivers. So if it was overheating here on the core, on the V core, then maybe that problem will go away. And that is pretty much it. Now we just need to send it to the customer for testing. I will not be charging anything for this because I don't know if you can spot that, but there is a tiny sign of overheating, of melting of the socket over here, right? I gave it a pretty good visual. It seems fine to me. It didn't deform, but the surface, as you can see, started bubbling. So for that reason, I'm not going to be charging for the socket or for the shipping. It's a local customer, so it's not, the shipping's not going to be expensive. Plus, I don't guarantee success, but as long as visually everything looks good. Here there are some visual problems with this, so no charge at all. And that is pretty much it. We'll see what it's gonna be, but as you can see, Some boards can be very much different. I checked the resistances again to make sure that there are no shorts on the core or any of the rails. Everything looks good. Visually it looks good. The socket is solid on all corners. It seems to be nicely soldered on, so I don't expect issues over there. Alignment looks good. It should work. It should work, but we'll see what it's gonna be. And if need be, we can just recap it if there's still any issues. But I'm pretty sure this will be the overheating problem, and that should be resolution here. So now after cleaning, hopefully the thermal the heat sinks will have better contact with everything, and maybe overheating will stop. We'll see. Alrighty, thank you guys very much for watching. I do appreciate you, and I shall see you in the next one.